I bet you get called on a lot. All right, so that was a weird comment for me to make. I don't know. Anyway, I'm going to even separate it more. If the degree of the numerator is bigger, no asymptote. Give me another possibility. If the numerator is smaller, and when I say that, I mean if the largest exponent on a variable in the numerator is smaller than the largest exponent on a variable in the denominator, which now it feels worse. Where's my asymptote? If the numerator is smaller, y equals 0. There's 1/3 possibility that everybody wants to use this right off the bat, and I've seen it in here, I've seen it in first hour, I've seen it year after year. Everybody wants to try to, for lack of a better word, cheat their way through it. Everybody wants to just assume this is always the case. But it's not always the case because there's 3 possibilities. If the largest variable on a, okay, the largest, I'm just going to use degree because I'm going to get like, bleh. What if they're equal?
Then there's no time.
There's a y equal, so there is a horizontal asymptote still. It probably is going to be a fraction. I mean, really, it will be. Leading coefficient, LC of which piece? N of x, over the leading coefficient of d of x. So last little part. It's awesome if you can answer this question and say, oh yeah, it's LCN over LCD. But we're in that same semantic issue. I'm going to write something here, and I guess we'll just use this one. Everybody can answer it's the leading coefficient over leading coefficient. This is what I hope everybody really truly can answer. If we look at number 1, and we'll do this problem together here in a minute, what is the leading coefficient, Wenzel, on number 1 on your page or on the board? What's the leading coefficient of the top? What is the leading coefficient of the numerator on number 1? Say it again. Why 2? So, and this is an important part because we really need to find these. And please, please, everybody, not just David, he's just who I'm talking to right now. If there's something that you answer and you know it's the answer, but you don't really know what you're saying other than it's the right thing to say, it's really hard to tell that from my perspective. Please tell me. Like, it's okay if you don't know what the leading coefficient is until you try to use this to do it, because then you're not going to be able to do it. David, the 2 that you gave me, that is the biggest power of an x, right? This is the degree. 2 is the degree. What is the number in front of that term?
1.
Do you agree that there's a 1 there? Even though we don't write it, if I just say, here's x, it's 1x is what I'm talking about. Are you okay with that? Are you really okay with that, or are you just saying yes? Okay, so check it out. I'm going to give us a wonky order. Nobody shout this out. I want you guys, just real quick, we'll check. Don't shout it or yell it. I want you to tell me the degree and the leading coefficient of this. You can write it in the margin. You can think it in your head. I'm going to give us about 10 seconds. If you're not sure, please tell me. I will come help you figure it out. We're going to get down everything. We're going to figure it out. It's in a weird order, I think. I would pay very careful attention. What is the leading coefficient and what is the degree? That's all that I want here. Of this. I agree with your first part. Okay. What's the biggest power of x here?
5.
Okay, so we're going to try that again. Biggest power of x. This is the biggest power on the x, right? So,
Sorry, doesn't go.
nope, but we're not there yet. We're talking about degree first. The degree of this thing, and I'm just going to write degree. And you guys don't have to write it. I just want to make sure we're here. What's the biggest power of x?
Power 5.
5. That's my degree. Now, the leading coefficient is always attached to the biggest term. This is in the wrong order. How should this be written?
4x to the 5.
All right, so we call it the leading coefficient because when we write things like normal human beings do math and we write it in the right order, now this is the very first number. If it's in the wrong order, you got to be careful. I can see that it's in the wrong order. The number was a 4. When I write it in the correct order, what is the leading number? The very first number that I write down.
4. Oh, wait.
When it's in the right order, so this one. So that is my leading coefficient. It's the first coefficient I write. If it's in a wonky order, we got to pay attention, but the leading coefficient is a 4. And the good news is that 99% of the time we get them in this nice general form here, but I'm just making sure we're prepared for the curveball and we're cleaning up the language. Wenzel, do you feel better about leading coefficient now than you did 5 minutes ago? Do you feel better right now than you have for the last 3 weeks? What should you have done at any point over the last 3 weeks just to really make sure we're all on the same page? Did somebody just answer that question for him? All right, cool. So, you're killing me. All right, so we have a couple more. Holes. I'm going to sneak the whole part up here. And let's look. You're going to have to turn your pages a little bit, unless you're going to go from memory. How does one find a hole in a function? I believe this was yesterday or the day before's discussion. I see you turning the page, which I appreciate, but actually look at the pages too. Were you though?
I'm holding my breath because I need oxygen in my brain.
I think you just need to. That's how you do it. Love it. Where did you find it? What section is that in? 4.3. So, if a factor divides out, which here we are again, when a factor divides out, which when I say a factor, and this is a harder one, but what do I mean by a factor?
One factor.
So how would I pick out one factor? Like, it's almost as though I was anticipating asking you a bunch of these questions. What are the factors? I went to the back page just for a brief second, so you know. On number 3, in the numerator, what are the factors? One of the factors is 2x plus 1. What is the other factor? Now, I don't want you to change this, but I'm going to give you one more here. I want you to tell me the factors, and I'm going to write it in this nice form. How many factors have I written? So I hear 2 and 3. So we're kind of split. Okay, well, let's check. What's one of the 3 things that I'm multiplying? This is a factor. What's another thing that's being multiplied? That is a factor. What's the last thing? So who is right, the 2's or the 3's? Well, no, don't do that. There are 3 factors here. Like the factor, it's the pieces of the product. Say that again? Well, I mean, this one had to come from an x cubed, so there's 3 factors. If it's an x squared, there'll be 2 factors. And we know that because we saw the fundamental theorem of algebra last chapter, which it's been a while, so you might not remember it. Number of factors is going to be equal to the degree. Every time that will happen. Okay, so when a factor divides out, what else do we say?
The 0 from that factor is a whole of the factor.
The root. Or 0. Like, you're okay. You can say 0. I'm okay with that. I'm going to call it root. You can write 0 of that factor is a whole. Now, if I now ask, when is there a whole, you can all read this, right? Like, you could give me the answer right now. Is a whole. I'm going to give us an example here, and then we're going to do at least one together, and there's going to be a lot of work time today because I want you guys to practice. Do you think that just having all of this information right in front of us is going to help?
Yeah.
No, because you already know how to do it, or no, it's for another reason. Well, I'll pick that apart with you in a minute. Kian, are we going to graph what? We will be graphing. I'll give you a sticky note so you can just put it on for top. I'm fine with that. We will be graphing, yes. What if we don't graph? I mean, you'll get half credit. Yeah, like your choice. I guess you don't have to. But, all right. So we're going to do a quick example here. Let's say that I had something that looked like this. 2x plus 1 over x plus 2 over 2x plus 1. So this is the form of it. First off, and we're going to hit a bunch of them. How many factors do I have in the numerator?
2.
There are 2 of them. Kian, give me one of those factors. And Benj, give me another one. X plus 2. Lagley, how many factors do we have in the denominator?
2.
How confident are you?
Not very confident.
Probably less after that question. How many pieces are down there? Like, if we wanted to say there's another thing multiplying, we can always think about it like this. I have 1 times 2 things or 1 times 1 thing? So kind of. Let me figure out how I want to rephrase this. Can this be broken down further? Like, as a binomial right now, can it be broken down any further?
Yeah.
How?
If you put the 1 on the outside of the parentheses, and then it's just x plus 1.
So you're saying if I add the parenthesis right there?
Yes.
So,
then, yeah.
but notice that's different because now I have 2x plus 2. So we get something different in that situation. For this, it looks like I just confused you. We're going to try something else. If I go back to this, and I'm going to rewrite it here. Now, how comfortable are you with a calculator?
Comfortable?
Okay, if I asked you, and I'm going to make you prove it real quick. I'm going to make everybody prove it. Do you guys have calculators handy? Do you need to come grab one? Okay, I would grab a yellow one if you need one. I want you to type this into your calculator. And I want to see, we're going to see how comfortable you guys really are, because I don't think, like, I think you had a silly mistake. These ones are going to be harder.
Oh.
But no, we can use those, and we can just do a different one. Yep, you can grab those. And Kian or Wenzel, that's fine. I'm going to give us a slightly different expression so that we can type it into the calculator. Okay, I want you guys to figure out using your calculators. Don't do it in your head. I want you to give me this answer.
Okay.
Okay.
What?
You just give me that. I just want you to type it in. Don't do it in your head. Type it in.
How?
I want 2 times 3 divided by 4 times 6.
Oh, yeah. No.
Okay.
I think so.
We're about to, I don't know if you guys use Facebook or anything, but we're about to get into Facebook land where somebody will post, oh gosh, people are so stupid, it's this. And then you get like a million other comments of people bickering, and it just turns out that nobody knows math. I'm going to do it first in my head, and then I want you to, we're going to do it the other way. Charlotte, what do you get? I'm going to write all the different answers we get, because we'll probably get a few.
Wait, what?
Don't care. Give me one of the things you get. 9. Give me another one.
1.3.
1.3. Give me another one.
0.5.
0.5. Give me another one.
0.25.
0.25. Good news, or bad news, I don't know. 4 people, 4 answers. But good news is I figured something out here right now. One of these is right.
9.
It is not 9.
What? 0.5.
So-
0.5. 0.2.
Let's check. Let's just do this in our calculator without it first. Help me out here. What is being multiplied in the numerator?
4 and 6.
It's 2 times
So numerator.
2 times
2 and 2 and 3.
So if I said right now, what are the factors that you see in the numerator? Can you tell me? What 2 things are being multiplied to make something bigger? 2 and 3. There's 2 of them. We all agree it's 6.
Yeah.
What about how many factors we have written in the denominator right now? 2. What's 4 times 6?
24.
What's 6 over 24?
1.5. No! Hey!
It is 1/4. Now, here's what, good, this is important. I want you guys, before I just answer the question, and before yell, I think got the same one, right? Do not give the answer to your classmates, okay? I don't know how you typed it in, but I want you to just give your answer. I want you guys to play around with typing it into the calculator. Figure out how we make it 1/4. I want you to make your calculator give this calculation of 0.25 or 1/4. Sorry? In one thing, I want one expression typed into your calculator. I want you to get 1/4.
What? Is like
4.25.
What did you put?
No, I want you to do it in one line.
Yeah, 1 line.
One line of typing. You can't hit 2 times 3, enter, and then divide it by something. I want you to do one single line. So you did 2 lines. Try to do it one.
What? Oh
Because
my
I see
gosh,
that I see you did
got
6
you.
and then 24. I want you to exactly type in. These are the buttons you have to hit.
So,
It might not be all of them, but we're gonna go back to this down for a second. We're gonna go ears opener, more open. Cool. You have to type one line. You can only hit enter once. You need a 2, a times 3, a divided by, a 4, and a times 6. There might be other things you have to add. What? I said 4. A 2 times 3, a divide, and a 4 times 6. I think you know it. I know you know it. You're right. I don't know if, did you do it in 2 steps first? In your head? Or show me.
now we got 9.
Ooh, so check this out. I'm gonna grab my other calculator because it's gonna do better with pretty print. Actually, we can just do it here because now we're still in this Facebook. Okay, Kian, Give me key for key in the order that you typed it in. What did you type?
2 times 3 slash 4 times.
If you're typing this in, you're going to get 9.
Yeah.
If this is what you type in. But let's go through and pretend we're on Facebook real quick. Okay. Yeah. So the Facebook comment is because of stupid things where it's some problem like this and nobody can agree.
What's like the ones with PEMDAS?
Okay. So this is PEMDAS. This is PEMDAS. If you don't notice it, this is PEMDAS. What happens first?
Oh!
Parentheses.
So I don't have any parentheses written right now.
Multiplication.
Wait, no, what?
It's multiplication is what should happen. What should be in the numerator? We know it needs to be 6. Can I add any parentheses here to say, oh yeah, make sure you separate this?
Yeah.
Because with what I have typed, let's just work through. It is 2 times, what's the next thing, the way we've written it? If we just follow straight through. We do left to right with multiplication and division. So we have 2 times, the next one is 3,
I think I got it.
divided by 4 times 6. This is what you've typed in, if you got 9. Is that the same thing that we had written? How do we fix it?
I got it.
How?
Wait, is this right? I might be wrong. Wait, I think I'm right.
You're
We got it. We got
much
it.
closer.
Oh, right?
Now, I'm going to have a challenge for you, Ken. And for everybody. And I've made this comment, but if it hasn't clicked or if it didn't really mean anything when I said it, that's one of those things. If I add that, and I add that, type that in.
Oh, dang, it was close.
We're going to get 0.25. Now, if we need to make this note, we should. The reason that we're talking about these is to be able to see the factors. 2 factors. You guys killed that. That question was good. And I know we don't use our calculators a ton, but there is grouping in parentheses when we do fractions like this. We don't always put it, but you're allowed to, and maybe it would be helpful if on every single one of these, we had parentheses around all of it. That is going to make it easier to see what is truly there as its own piece, even if it's a single. Okay, so if we have this then, and we're going to kick back to it. Let's say I had this one over this. Does any, and I'll even do my parentheses, is there a factor common in both the numerator and the denominator? What is it? Okay, so I'm going to rephrase this. What is the factor that divides out? So this one, we'll do this wordy on another one if we have to, but before I've just been saying what divides out, and you guys tell me x plus 2. I need to be better with language. The factor x plus 2 just divided out. Like that's the same thing that we've been saying, but now it's the factor. Now, if you look at this, and mine's covered, how do you find the holes? Something about factor that divides out. And at this point, I see everybody still looking up here. I want you to take your eyeballs and your neck muscles, and I want you to turn your head like, I don't know, roughly 130 degrees downward. Hey, how do we find holes? So too far, you're supposed to be looking at your page if you didn't catch that.
Factor divides out.
So we have a factor that divides out. And if I said, well, how do you find it? You guys can all tell me the root from the factor. But here's what I care about. Here's a factor. How do you get the root from this factor? We simply set this equal to 0. And if we want to see this, what we said way earlier this year, and I know you guys don't remember everything, and that's okay, but a lot of these ideas, we're going to keep referencing them, so if they don't stick yet, they will. We have something that follows. If x equals a is a root, and this is an old one, then x minus a is a factor. Do you ever remember seeing this? If not, it's okay. Is that the whole year's worth of notes? Can I steal it again real quick?
Yeah, what chapter though? Because there's a lot in here.
Chapter 3. Anybody's notes would be okay, but I like to read pictures right. I actually think you can read almost everything, but you guys all have nice. Anywhere we're doing division.
3.6.
3.6, do you have long division and stuff? Anything that's synthetic to long division?
This
We can put it. So I'm looking for long or synthetic division. So I'm looking for. I'm sorry, you were.
Long division.
Oh, check it out.
No, it's unreadable.
It's not at all. I'm gonna go back and take. Okay, I'm going to make a claim here that we've used this idea and we've used it a lot. And it's been a while, but I want to see it happen right here. Okay, do you guys remember doing these?
Yeah.
What is this? So I just want to really quickly do something. We divided by negative 2/3 and we got 0. And this is a throwback, but then right here, I see this lovely arrow that says this implies something. If negative 2/3 is a 0, then this is that exact idea that I'm referencing. I just want to show you that we have done it. We can move between factors and roots easily, and that's all that's happening. Thank you for this, by the way. Good job finding it. This idea is huge. The factor that divided out was x plus 2. We get the root by just setting it equal to 0. Alternatively, we could say the root that divides out, and it's a little bit weirder to say that, but the language works, and we could go to the factors. Okay, so all of that, we have those. Last little question with this one. If x plus 2 just divided out, where's the whole? At negative 2. And remember, because if the factor is x plus 2, to find the root, we just set it equal to 0, and we get the root is at x equals negative 2. Awesome. Good job. Okay. How about x-intercepts? And this is the last one, and then we'll take a quick brain break.
Oh, yeah.
X-intercepts. How do you find the x-intercepts?
Find the root, find the solutions.
Of what? Of what?
X.
Good. That's what I need to hear. We're going to say the x-intercepts are the zeros, the roots, the solutions. I'm going to say zeros of the numerator. Now, just like we did before, if that does not tell you exactly what we need to do, you need to say right now. You can say that it's the zeros of the numerator. Do you know how to find the zeros of the numerator?
Yes.
What am I asking you to do, Kian? Set what equal to 0? Which? So I'm going to say set each factor equal to 0. Every factor of the numerator. Now, this is a pretty good review. I'm going to be honest. When you go to make your note cards, because we only have one section left, but this is a pretty solid note card as far as graphing goes. I would not throw this away when we're done with it. I'm going to make you guys hand it in tomorrow. I would keep this. This is exactly what I would have on my note card. Maybe fewer words if it were mine personally. Maybe more words. Up to you. You need these. All of this. Okay. Quick brain break. And it's going to be fairly quick because I know we've done a lot of stuff, but we haven't done anything new. We're in a math class, right? Is it reasonable that you think I probably do more math than you?
Yes.
I better, right? I teach 6 classes per day. I do a ton of math all the time. Which means when I see a new word that I don't know, I'm looking at it from a very mathematician point of view. Would you agree? What do you guys think it means? And I'll tell you, I do this. I try to live my life circumspectly.
Like around.
That is 100% where my mind goes. What do you mean around? It's an adverb. An adverb what? What? No, an adverb. What is an adverb?
Like describing the action.
Yeah, I can jump quickly. Jump is a verb, quickly is how I'm jumping. So, it's an adverb. My mind immediately sees circum, and I think circumference. Like, immediately is where I go. Or circumnavigate, or there's other words, but my mind goes to geometry and circles. It's nothing to do with circle, which is weird, because I don't know why this isn't there. Somebody in 3rd and 4th hour said, oh yeah, it makes me think of circumstance. And then I realized, well, why don't I think circumstance in circle? To do something circumspectly means that you do it in a cautious way. You're wary about it. Okay, I've never seen this word in my life. Nothing to do with the circle, but I am a pretty cautious guy, typically. Okay, real quickly, we're going to give one more minute because that was a really quick one. 60 seconds. I have a group of 2, a group of 3, and a group of 2. It is Wednesday, and what's Wednesday's alliteration for brain breaks?
Hump day.
So that's not alliterating. Whine about it Wednesday. In your small groups, you get 60 seconds. I want the best or worst, I don't know how you're going to decide this, from each group. Whine about something in your personal lives that you're welcome and willing to share with the classroom. So, whine about it Wednesday. Oh, nope. Oh, Boyer's Day Thursday. I didn't look at what it means. I have no idea.
Wait, we're ranking how bad we are?
No, I mean, but you two independently are. So check this. Does everybody here have something to complain about right now? I want you guys to complain about something together, and whoever's is better or worse, I don't care how we think about that. I want one of them to get shared. Kian. Yes, sir.
Well, no, you gotta tell your feeling, my guy.
Yeah.
Yeah, you can do it.
What do you got?
Yeah.
Oh,
Dr. Morgan, I'm gonna make you share one of them.
Anything, anything. You don't have to like.
Any
complaints going on with you?
Okay.
A sequel's not getting a sequel. A movie's not getting a sequel.
Don't know why.
Weird. You need to like come back. I
I
didn't even
I
think
mean,
about that.
that's.
Yeah.
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 What is?
It's turned.
Big
Let it
I
put it down.
don't know why.
Let it wait. It takes a while.
You gotta remind about.
Yeah, growing pains and
Yeah.
like still crying about and stuff. Stressed so tired last night, she was whining at 2 in the morning. It's just.
Bad.
All right, whine about it. What do you got? Whose is better or worse? I don't know.
I don't know. We can have the same. We have the same.
Even or odd? It doesn't matter if it's the same.
Even.
What is it?
We have to go to all the electric service.
Fun.
Right after school, we have to get in the water and do electric.
Oh, cool. I'm gonna let you guys pick real quick. We're gonna do one of these together.
Okay.
I want you to look over these 4 fairly quickly and decide which one are we working together and which 3 are you gonna do.
2, 1, 2, 1. I don't know. I'm just making.
Yeah, two. It's the only one with the, not a one.
Honestly, why not?
Yeah, it doesn't matter to me. 2?
Don't say.
Okay, so we're gonna do number 2 here. Now, we'll review the graphing part because we're gonna hit a few more things there. And I'm gonna make one more comment on mine. I'm gonna do a different color. I want this one to stand out. I know we're gonna eat into some of this space, but I wanna make a comment right here, underneath x-intercepts. So I'll go back to orange. I want you guys to make sure you have this comment. And you've heard me say this a million times. When I say how many x-intercepts are there on a graph, why do I ask that?
Because when you drag there's always two.
So maybe, I don't, maybe. I'm not quite sure. Can you say that again, Kian?
When you factor, right? Like let's say you factor number one, you always get two parentheses with.
If it's a quadratic, yes. But, so why do I always ask, like, when we're graphing them? Because the graphing part's where things get also struggle. How do we decide, how do I want to word this? Where's the, I'm going to just change it. When can a function change from being positive to negative? There's only a few, small handful. And what I mean by that, and we'll go back to this here, I guess. What I mean by that question, look at this. It's all over the place here. If I have a function that has this asymptote, and we're just going to make one up easy. This is the only asymptote that I have, and I find this. How many times is this function going to cross the x-axis? Once. Why once? How did you know that so fast right away?
Wait, she gets.
No, you don't psych yourself out. You're good.
I do, but like, now that you said that. Okay. Because. Oh, now else would you about?
Where can a function cross the axis? So I just, you know, I can't tell where you're pointing.
Right there. I don't know. Yeah. Right
What?
there, right?
Why here?
I
So,
don't know.
I'll make it more clear here, I hope. There's the x-axis and the y-axis. I have given you 2 points on this so far. Not 1 point and another thing. What is this dashed line representative of?
Because it crosses the x-axis.
So, pause. We're going to take that idea. We're just going to get rid of it for now. When have we added dashed lines to our graphs? What are they?
That
Is this a vertical asymptote or a horizontal?
vertical.
Okay, so let's all agree that's a vertical asymptote. What is this one dot on the x-axis representative of, do you think?
The whole x.
So it's not a hole. I would have drawn a hole, but you're not super cold. You're not super far off. What was yours? The x-intercept. If this is the only x-intercept, is it ever going to cross anywhere but here?
Can't cross the vertical asymptote.
We can't cross the vertical asymptote for sure, but do you agree that this is the only place on this graph that I can cross the x-axis?
Yeah.
If I was going to cross here, what would be here?
Another point, right?
But I don't have one there. It's the only way. That is the other big idea. Now, we're going to see if we can put all those together, and if that didn't mean anything, the comment that we're going to make here, our graph will only, and I'm going to say two words here. It'll either touch, and then in parentheses it'll say or cross the x-axis at the x-intercepts. Now, this is a big driving idea that's going to, if we can grasp this and make sense of this and use it, we're going to save like 10 minutes per problem. Legitimately, I mean that, and I'm not exaggerating. For every single problem, we're going to save 10 minutes if we can really make sense of this. The only time we cross the axis ever is here at x-intercepts. Only time our graph will ever touch the x-axis. So let's look at these. We have that statement, and we're going to come back to all of that. Do you guys have everything here written? Okay. All right, I'll wait. While you're going, is there anything that we've done today, now that we're like 20 minutes after the fact, that we went over that did not make sense? Okay. If no, you're okay. If there's nothing like right away that says, oh yeah, I didn't, that's okay. If we wind up finding something during the problem that doesn't make sense, what's your job? Oh, right away, please. Yeah.
I feel like I understand what holes are, but like, I don't at the same time. Like, I get it, but I have a hard time like doing it myself.
Okay, so like finding them or making sense of what it is?
Yeah, kind of making what sense of what I do.
So what it is just one point that breaks our function. Like it makes us divide by 0, but it falls out. So we don't want to have an asymptote because I have to cross it, but there's one place where it's just undefined. Okay, and if that doesn't really answer it, we'll look at it. But here we are. Let's do number 2 together. Do we need to factor together, or do you guys want to factor on your own? Okay, I want you to do the bottom alone. We'll do the top together if you'd rather do that. So let me know when you're ready, and we'll look at the top together. I'm going to give you a head start. If you don't know how to factor, don't just wait for me to write it on the board. If you have no idea what to do, please ask. Let's make sure you get it. It is a fundamental part of being successful with algebra. Kian, I'm going to tell you, more than recommend, I need you to show your work with it. Because you and I both make a lot of mental mistakes when we're doing stuff. I'm going to avoid them. I want you to avoid them. Okay. I'm going to come and be nosy. I'm just going to check all your denominators. Love it, I think. Pretty sure. Wait, another question.
These are not this.
Ooh, is this broken? Are you doing the bottom?
Yeah.
What are these add up to? Okay, so you're right, they do, but
Okay.
when we do this, what do they multiply to? You mentioned those. What would they have to be?
Oh, 6.
Okay, so your numbers are good, except they add up to the numbers. These add up to, sorry, they multiply. Yes, we multiply. So 1 and 6 doesn't cut. Well, give me another number that goes into, so 1 and 6, they add up, it adds up to 7. 6. We do, but 1 and 6 add up to 7. So if you just change 1 and 6, you make it both positive, you would get a 6, but you would get a 6x plus 1x equals 7. So this was a difference, and then once you cross it out, we need another character. Instead of 1 and 6, we need another 8 and 7.
But my question is this
What are those?
negative 6,
Those are.
negative 1 plus 6?
No, that's the multiple. Yeah, those two multiples are -6.
Oh, because you have to like show the one that
Where's this?
gives up this.
That's where it multiplies.
So let's do the denominator, let's do the top together. So there's something working out here, so we'll figure it out. I want you to write down the denominator. All right. So let's look at the denominator. Weird. We're going to look at the denominator real quick also, just in case. So I'm going to do all my scratch work here, and then I'm going to put a sticky note graph over it. Okay. So let's look. If I'm looking at just the denominator, I have x squared plus 5x plus 6. X squared plus 5x plus 6. How the factor do I do this?
A and 6.
I'm going to multiply A, which is my leading coefficient. What is the leading coefficient here?
1.
1. There we go. So I multiply these, and I get 6. Now I need numbers that do what?
1.
They have to add up to 5 and multiply to...
1, 6.
Hold on, I didn't say 1, 6.
Okay.
1 times 6 is 6. Give me two numbers that multiply to be 6, but they add up to what?
5.
So I'm going to start. Is it plus 1 and plus 6?
No.
Why not? They would add up to 7. Give me another combination. Plus 2 and plus 3. Do those work?
Yeah.
Awesome. Why don't I have a whole lot of work in front of me now? Something special about this. There's a shortcut. How do you know there's a shortcut, Beatrice?
Because the leading coefficient is 1.
Love it. If the leading coefficient is 1, and only if it's 1, we get a shortcut with these numbers. X plus 2 and x plus 3.
Question.
Answer.
Why can't we, like, I understand positive 1, positive 6 equals 7, but how come we can't do negative 1, positive 6?
If I do this, and I'm thinking out just the parts of FOIL, what's the last number that I get out?
What do you mean?
When I finish FOIL, so I do x times x, and I do those, right? Then I do that, and I do this last one, and I'll get rid of this. What's the very last part of my multiplication? The last times the last. We have a negative 1 times 6. Gives me what?
Negative 6.
But was our expression minus 6 at the end? Like that's why it doesn't work.
Okay.
Like we have to have it to be the equivalent expression. It's just going to be looking different. Now for this other one, the numerator, we have a little bit more work to do, but the same approach is going to start us off. 2x squared plus 5x minus 3. I do not have a shortcut. Why?
Because there's,
Gosh, that dang 2 kills it, but that's okay. We start pretty much the same, right? I multiply a and c, so I do that. 2 times negative 3 gives me... I now need to find my two numbers that multiply to be negative 6, but add up to what? 5. Now, a couple things that I noticed right off the bat. I'm going to run through the whole list, just for the record. One of these numbers has to be negative. And I know that because positive times positive makes a positive number, but so does a negative times negative, but I need it to be a negative in the end. So 1 positive, 1 negative. If I start here, these might be the right numbers. Which one has to be negative?
1, 1.
Why?
Because if you add that,
I need them to add to 5. So I use these. Now, the most common mistake that people make is now they're going to try to do x minus 1 and x plus 6. But we can't. There's no shortcut for us, right? So what do I do with these two numbers? What am I replacing in the previous expression?
5.
I'm going to replace 5x with these, minus 1x plus 6x. So we're going to change our trinomial or trinomial into a four-nomial. Now, I would advise, you don't have to, the order doesn't matter. I always do the minus first. So there's my minus 1x, and then I'm going to do plus, there's my positive 6x minus 3. If you do it the other way, it's okay, but it's weird because instead of saying minus 1x, I would say plus the negative x, so we don't get goofed up. I now will add grouping, which is the whole point of making an even nomial. I have 4 terms. I can do 2 groups that are the same size. What could I possibly take out of this group? When I take out an x, yell it, what do I get?
2x.
2x minus 1. If I'm right and correct with my factoring, whatever I take out of the next group, what's going to be left inside the parentheses? It has to be the same. If they're not the same, you're wrong. What could I possibly factor out of both of these? A 3. And if I take out a 3, it's a 2x minus 1. Do these match? So what's one of my 2 factors?
Minus 1.
Love that I heard both of them. One of them is 2x minus 1, and one of them is x plus 3. Okay, we have our completely factored form. If you are struggling with factoring, it happens. We're going to get you there. Like, please come see me. I'm going to keep giving you problems over the weekends. I'm not giving you problems just so you can Google how to factor this and then write down the answers. I'm giving you the problems so you can practice. If you think you might Google or GPT or whatever various option you might use, come talk to me. I'd rather teach you than just have you write the answers. So, we're here. We're factored. Get used to it. What's next? Is there a simplified form that we can go to?
Yeah.
Do we have the simplified form?
Yes.
Are you sure?
I'll look them up right now.
What's the difference between a factored form and a simplified form?
Oh, we need to
Oh, yeah, the
find out the.
So let's be more specific. I'm going to ask this question much better. Is there a factor that's common in the numerator and denominator that divides out? That sounds ugly, and maybe that makes it worse. Do I have the same factor up top and down low? And I see it's x plus 3. What's x plus 3 divided by x plus 3? So they divide out, and I'm going to already take my pencil, and I'm going to go all the way down to here. Why? X plus 3 just divided out. That's a factor. What's the root that you would get if you were to take x plus 3, that factor that we divided out, and set it equal to 0? There's our hole. And all that means is when we go to our graph, once I draw it at -3, I'm just going to make a hole instead of a solid curve. It'll just be a hole in my graph. So that's good. It means my completely simplified form is simply 2x minus 1 over x plus 2. Have I lost anybody in that last step? Okay, last question. Why don't these cross out? So kind of. I don't know that I like that answer though, because in my mind, Kian, I want to look at this and say, well, those would divide out. I don't care that it's the coefficient's different, but there's something important that we looked at the start.
Right, because if it's 0, you said something about it. I remember talking about it. Or if it was -1. No.
So check it out. I'm going to rephrase this question a little bit. Is there a factor in the numerator right now? What is the factor? So if I wanted to make it really clear that that's a factor and it's its own piece, what could I put around it? Like, oh my, parentheses. The second that we do this, now I'll just look and I'll say, I know the factors are in parentheses. Is there a factor that's common in the top and bottom right now?
No.
No. Even like they both have an x, they do, but the whole factor does not match the whole factor. Nothing else divides out. From here, the rest is easy sailing, I hope. How do I find the vertical asymptotes? So d of x, what is the denominator here, and what value of x makes it a 0? So good, I'm dividing by this, right? This is my denominator. If I take that denominator, which is x plus 2, and I set it equal to 0, what do I get for x? X equals -2. Now, if you have this little scratch work, I'm just going to connect them to make sure I can see them when I'm looking at it later. I took the denominator of this, just like it says. I took the denominator, and I found the zeros. There's only one this time. Awesome. Okay, what about horizontal asymptotes? Which of these three forms should we look at? Sure. We can look at the first one. I would say the first or the last. I probably wouldn't look in here because it's a little bit harder to see it. Up top, what is the degree? I'm not trying to point to it. I just happen to be trying to point to the stuff. What's the degree of the top here? And how do you know that? What is the degree again? When I ask what is the degree, how do I know that you didn't just look at that too and decide that's the degree? It's the biggest power of x. What is the degree of the denominator? The degree is 2 because it's x squared. And I'm going to even put that afterward. X squared and x squared, just as a little reminder. Okay, let's compare these. Degree equals 2. If it's the same up top and down below, how do I find the asymptote? When you say dividing the numerator and denominator, I want you to use one more word, the what of the numerator and the what of the denominator. To find this, we compare the what of them? The degrees. Are they equal, or is n bigger, or is n smaller? Are you sure? They're equal, so let's look. It's the LC. What does that mean? So you're right, Yale, just so you know. I know that you're right because you're telling me to divide numerator and denominator. I just want you to be more specific. I'm not actually doing the whole division. I'm only checking the leading coefficients. What is the leading coefficient, Lagley, of the bottom? Sorry, top. I'm pointing at the top. Sorry.
2.
So y equals 2 over Bagley. What is the leading coefficient of the denominator?
Oh. 5. Right?
So
Oh.
are we looking at the original or here?
But now I'm confused.
So what is the leading coefficient? The degree is 2. What's the number connected to that one?
X.
What's the number in front of it?
1.
1. That's our leading coefficient.
But I don't get it because we were just talking about how we could put it in a different order.
Yep, so do you agree that this is the x that has the biggest exponent?
Yeah.
What's the number in front of it? That's all that we're after. These are in the right order, so it happens to be the very first one, the leading. It makes sense in that frame. And I did give you the one with the weird order, but notice when we put it in the right order, it was that very first number again.
Why would we put a 1 behind?
Go ahead.
Why would we put a 1 behind?
To be diligent and to make sure that we're paying attention. I'm going to write one more. What's 2 over 1?
2.
Yep, yeah, I'm okay with going there. Okay, we almost have everything. X-intercepts. Okay, what's my follow-up question going to be for you, Kian? What do I set equal to 0? So this whole thing, I just put equal 0 here and solve it? Read. Check your stuff. Love it. Say it again, David. Let's take this and set this numerator equal to 0. What's the only factor that I have in the numerator right now? There's a factor, one factor in this numerator. What is it? Good. And I'm going to set it equal to what?
0.
Help me. What do I do?
Add 1.
Add 1. 2x equals 1. Divide both sides by 2. X equals 1/2. Where's the only place that my function is ever going to touch the x-axis? At that x value, right at 1/2. Now, we have like 2 minutes left, and I know it might not seem like it, but we do have enough time to grab it. I assure you. So if you'll take one and pass it down, I want to rip it in half. So we'll start on both sides. Well, these are solid on both sides. That's weird. Here's 5 seconds.
Yeah.
They're sticking on both sides. All right, take one and that's the one. Okay. So there is an x and there is a y. We're going to add all this information. Now, here's the deal. We're going to run out of time. I'm going to talk until the conclusion of this. You can leave at 3:15. Like, everybody's allowed to leave at 3:15. I'm going to keep talking to this video for like another minute if I have to. I'm going to put my asymptotes on. So let's see. I'm just going to let each one of these is 1 because I already see there's ticks on it. I'm going to use those. So let's see. I need to have a vertical asymptote at -2. It's right here. Okay. I'm going to put the horizontal asymptote at 2, which looks like it'd be right there. If you would like to leave, you're welcome to. I'm going to keep talking to either whoever's here or an empty room in either situation, just so you know, because people on the road probably would benefit from seeing this. Okay. Any other points I can put on here? And for real, like, I won't judge you. You're welcome to stand up and leave, but I'm going to finish this problem.
-3.
Good. Careful, almost. Where's the intercept?
The x
Yep.
x
Equals,
-3.
you give me the whole. This is the only place my graph is going to touch the x-axis. I know it's not going to cross this. It can't cross it. Now, for this, it is going to cross here, and it's going to mellow out along the horizontal asymptote. It has to. It's crossing and it's mellowing. Now, this is where we were getting hung up yesterday, and I want to see if we can do it without making a bunch of extra points. Does the graph have any chance? And I'll wait till everybody's looking. Does the graph have any chance of being here? Can you tell me why not? This is the only place that I ever cross the x-axis. If it's not going to cross over here, it can't be down in this area because it would have to cross. If it can't be underneath right there, where's the only other option? So it can't be over here. It has to be somewhere on the left. But if it can't cross, it must be up here. It can't cross the x-axis, and that's the only way that we can draw that curve without it crossing. Okay, tomorrow, I need you guys to come back either with this done at the start of class, or I need you to come in at lunch tomorrow. If you can't do these in 30 minutes, that's okay, but I need you to tell me you can't. We're going to find one-on-one conversation how we're going to make it so you can. All right, you guys have a wonderful day. I appreciate the heck out of everybody staying for an extra minute and a half. 2 minutes. Thank you guys. Did that help today?
Yeah.